Hey everyone, I'll just be waiting for a couple minutes to let a couple people get in, and then we'll start.
Yeah, they have other, I don't know. I respect the sentiment, but I don't think oh, that would actually explain a lot. Well, yeah, what is the don't cross the picket line? Telling us don't cross the picket line.
Talking about
Don't cross the virtual picket line, which is going to class, I guess.
All right, so before we start, if I can ask anyone who's not gonna talk right now, can you just mute yourself? And then if you do want to ask a question, go ahead and unmute yourself. So let's get started. All right, so welcome to EECS 281 Lab 1. Oh, how do I present? Present, okay, there we go. EECS 281 Lab 1. So EECS 281 seems like a pretty tough class, but I promise you, you can get through it. So let's start. My name is Rushal Cassetti. Here's my unique name. I'm a third-year student. This is my second semester teaching EECS 281. Well, last semester I did not teach a lab, so this is my first lab. So it's as new to me as it is to you. So before we get started, let's just do some announcements. Lab 1 is due Friday, September 18th. So not this Friday, next Friday. You always get an extra week to finish the actual lab coding assignment. You do want to start it early though, because if you do your lab assignments near the deadline, you might get into a little bit of trouble with the higher workload labs. Some of them later in the semester do take a lot longer. This first one isn't too bad though. And you don't want to be losing points on lab assignments, especially since projects and exams will be a lot harder. So project 1 was released, I think, last night, maybe 2 nights ago, and it's due on the 22nd. So this lab, we'll just be discussing some 281 general success tips, Makefiles, Valgrind, perf, C++ input and output. So no and the beginning part won't just be like regular C++ concepts or algorithms or anything. It's just going to be like getting stuff set up so you can actually do well this semester. Then we're going to work on parsing command line options using Getopt, and I believe that's what the lab is about as well. And then we'll quickly go over abstract data types like stacks, queues, decks, and vectors. And then we'll end off with some project 1 tips, and I'll give you a couple minutes to work on the handwritten problem. All right. Also, we'll talk about some syllabus must-knows right now. So the midterm is Wednesday, October 21st, times to be announced. I'm not sure how we're going to be administering it this semester. I don't think that's been set yet. I'm pretty sure the date is right, but sometimes we do change it. And then the final, December 11th, I think that's set. I don't think we can do anything about that. So let's talk about the minimum competency rules. So to pass, you must have a 55% overall on projects, 50% overall on exams, and 75% overall on labs. So that means like even if you get like 100% on every exam and you get a 50% overall on the projects, you will not pass. Like even if you even if you like do the calculations based on this slide and you say, oh, I have an 80%, why didn't I pass? Oh, let me go back, hold on. It's because you didn't pass the minimum competency. So you need to make sure you get all 3 of these things. If you meet all 3 of these, you're also guaranteed at least a C. So say you get like the minimum things, like 55%, 50%, and 75%. Even if you do this calculation and you say, oh, well, it's a really low percentage, you are guaranteed at least a C. Okay, that's, yeah. Like it says down here, high exam scores do not compensate for low project scores. Okay, so lab recordings going over slides will be published every week. I think this one will be published, assuming I didn't mess up when setting up the recording. So hopefully this will be published, and I think it's going to go on YouTube. Normally they're going to be going up every Wednesday, but because we had a mistake yesterday, I think it's going to go up Thursday. Okay, so 25% of your lab grade is your handwritten problem. This one we're going to be submitting to Gradescope, and you cannot work on anyone else, work with anyone else on like the actual like implementation. You can talk about concepts and stuff, but the actual like hard implementation, you cannot work with anyone else on. It's a violation of the honor code, and you also can't turn in work for someone else. I don't know what that means, but whatever. So the handwritten problems are graded based on completion. So you don't have to get like 100% on all the test cases that they provide on Gradescope. You just have to finish it, put some effort in. So if you turn in a blank file, not going to get it. If you turn in a file where you just loop through everything, you might not get the points. But if you like genuinely make an attempt at the problem, you'll get full points. Don't have to worry about passing all the test cases. All right, and then the major part of your lab grade is like this main lab assignment. So you've got the Canvas quiz, which I think this week it's like 18 or 20 questions. And then there's also the autograde assignment, which is due on the 18th. Yeah, and so you can see those in the Canvas lab files. Okay, you can view, yeah, okay, there's recordings. Yeah, email us here if you have any issues. I think the admin team takes care of that because I don't get those emails. So here's our percentage grade breakdown. I'm sure that's like in the syllabus somewhere else, so you can look at it then if you want to. All right, so for the honor code. For projects, the individual general honor code is not any different from how it was in 280. So yeah, you can't collaborate on projects like you could in 280, but that's pretty much the major difference. Exams, it's the same, it's exams. Labs, you may work with a partner, but you have to both submit your code and answers. So say you say, okay, this is my partner. You actually have to both label in your code that this is your partner, and you also both have to submit the same code. Oh, I mean, it doesn't have to be exactly the same, but you do have to both submit code. We don't actually like officially register partners. There's no like you have to go on the autograder and say, okay, this is me, this is my partner. You just need to put it in the comments, and that's good. And you are allowed to submit identical code and answers as long as you're just working with one partner. And I think we have a Piazza thread for finding partners if you'd like to. All right, so some success tips. Start projects like right away. These projects are a lot harder than the ones you might have found in 280. So you might think, okay, well, I can just wait until maybe the last few days like you might have in 280. It might work, but it is definitely easier and you'll write better code if you start earlier. That doesn't necessarily mean you have to start writing code on the first day, but you do want to start like planning and like designing the structure of your code. Okay. Yeah, so we have a lot of office hours this semester. I think in the winter, we just hired like 10 extra IAs. I was one of those new IAs. And so because of like, by that we're just gonna offer tons more office hours. Right now on the schedule, it doesn't look like there's that many at night. That might change in the future, but just during the day, there seems to be a lot of office hours. I think I'm gonna be doing 4 hours a week. I think most IAs are doing that, and we have 36 IAs, so should be good. Right. You want to get used to like Googling and searching for things. So like stuff like C++ standard library functions, compiler errors, Linux and Git commands. You can like ask like on Piazza about them, but it will be faster for you if you learn how to search them effectively. So what I like to use for C++ standard library functions is CPP reference. It's really good. There's also c++.com, but I think it's a little bit more outdated. So CPP reference will have pretty much everything you need. So say I wanted to know about like the standard string libraries. I can do this. Oh, well, it takes me to standard basic string. But yeah, so you can find out everything you need here, all the member functions, stuff like that. Oh, 1 second. Yeah. Okay. You want to think about, okay, yeah, I already talked about this. Right, so lab 1, it's meant to get you comfortable with the tools that you're using and not necessarily actual code. Oh yes, in the resources folder, there is an optimization tips document. And the STLNU, those are really, really useful to read. The STLNU especially, I think is very helpful for, I think that one's helpful for the exam. Both of them are helpful for the exam, but optimization tips are especially helpful for the projects. Read the specs in its entirety. Yeah, okay, yeah. Yes, sometimes people miss stuff in the specs, so you do want to read them in their entirety and follow the algorithm on the specs. Okay. Next, so debugging tips. Write test cases and walk through your algorithm. Okay, I mean, this is kind of self-explanatory. Let's see. Yeah, print statements are helpful. I agree, but it's better to use a debugger. So Visual Studio has a good debugger. Xcode has a good debugger. And VS Code uses GDB under the hood, which is like a text-based debugger. That one's also pretty good. Okay, yeah, I'll read the specs again. Cement test case, the integrator. I think you got this. Okay, yeah, check on Piazza. Did anyone else have the same bug? That was very, very useful for me. Like, even if they're not explaining like everything about the bug, just getting a little bit of insight on it can really help you like determine what's going wrong. I found that very helpful. And search, you don't have to ask necessarily. Like searching Piazza is, it's like the Piazza search is okay. So I've seen a lot of repeated questions, like that's okay, but it's just best to search. Use an IDE, sure. Yeah, so like, I guess if you're using like Sublime Text or Vim, I mean, you could. It's just probably easier to use an IDE or VS Code, which is like some IDE features, because like debugging is a lot easier in those programs. Okay, consider off by 1 errors and edge cases. Yeah, I think you probably dealt with those in 280. Test your branches and their conditions. Yeah. So write good tests, basically, is what they're saying. Okay, so right, after submissions are closed, your best submit is the one that's going to be run again. So there are a couple private test cases, but they're not like the same ones as they were in 280. In 280, what they would test in private test cases, or at least when I took it, they used to test like edge cases and like tricky things. Our private test cases are not meant to like trip you up or anything. They're just meant to make sure you didn't like game the autograder. You didn't like write your code specifically for the autograder test cases. I mean, they're not public, but perhaps like someone figured out like, oh, this test case works better if I do this. So our private ones are just to make sure no one like gamed the autograder, and it makes sure that like with like your code will work on like reasonable inputs that you didn't have access to. That's all they're for. And they're not worth like a huge percentage of your grade or anything. I'm not sure exactly how much, but it's not huge. Okay. Right, yeah. Oh yeah, so if 2 of them are tied, you use the most recent one. It's imperative that you start early. Yep, okay, that's what we said. Right, so compatibility with CAEN. So our autograder runs on CAEN, so your code needs to run on CAEN as well. Like it's possible that your code, you've written your code and it works great when you compile it with like, I think like the C-Lang compiler on Mac OS, or maybe you compiled it like locally on WSL with perhaps a different version of G++. What really matters is, does it work on CAEN with the version of G++ that they use on there, which is 6.2. And I'll show you how to like set that. Oh, well, actually, I'll show you down here. I'll show you how to set that up in a couple seconds. All right, so I will show you now how we log into CAEN, and that's okay. Oh, I'm already in CAEN. Oops. Okay, so to log into CAEN, just type SSH and then your unique name and log into engine.umich.edu. And then it's going to ask you for your Kerberos password. I think it's what it's called, but it's just your regular University of Michigan password. Oh, whoops. Duo. Okay, so now we're in CAEN. Okay, yeah, so what it says right here, right, is modulo GCC 6.2. So that's what you do to make sure that you're running GCC 6.2. And so you just type this. So that's the version you want to compile with. Mine is already set up like that because I modified my bash profile and added it in right there. So it automatically does that. Every time I sign into CAEN, it automatically runs this modulo GCC 6.2. And so if you want to do that, just follow these things and it'll add it to your bash profile. And that gets run every time you log into CAEN. Otherwise, if you don't want to add it to your bash profile, you have to run module load GCC 6.2 every time you log in. Okay, and then we can do GCC version. Yep, so it says 6.2. What's next? All right. Okay, so there is a service called mfile. I think it's just mfile.umich.edu. They don't want you to use it to transfer your files to CAEN, although it does work. I think something can happen with like corruption. I'm not exactly sure, but if you just don't use it, I guess. I've never actually had that issue, but it's preferable to use something like Git, rsync, SFTP, SCP, something like that to transfer all your files. I personally use Git. So we have like a Umich GitLab. Many of you probably used it in something like 280, but I don't think you were required to. So you have Umich GitLab, you have unlimited private repositories. Okay, someone asked, are these slides going to be posted? I think they're posted on Canvas right now in the lab 1 folder somewhere around there. Okay, yeah. So yeah, they provide unlimited private repositories. So that's what is really nice about our GitLab. You are required to make your Git repositories private because we can't have anyone seeing your code. There's also GitHub if you want to. GitHub also provides unlimited free private repositories now for students. I think for everyone actually. So you can also use GitHub if you like, but GitLab is like through University of Michigan, so that's what I use. So if you don't want to use Git to transfer, you can use any of these three: SFTP, SCP, rsync. I don't really know how much to use them. Well, sorry, I don't really know much about using them, but FileZilla is one program on Windows, I think, that helps you transfer using one of these protocols. And there's also a, I think, sync to CAEN command in our Makefile that should also use rsync. Okay. Okay, yeah, so leave plenty of time to debug because, okay, yeah, so sure. Your code is not always going to run the same on CAEN as it will on your local machine. So just make sure you're able to debug on CAEN. All right, so now we're going to start covering Makefiles. And someone asked, on Gradescope, the lab written problem has a due date of this Friday. Is this an error? No, there's no error. That one is due Friday. It's just the coding, sorry, the programming assignment is due next Friday. So this Friday is the one that's due just for like completion. There's no like error checking. You don't actually have to get it right. Normally what they would actually have us do, like if we were in person, they would have us turn it in like at the end of lab. So it's not like it's, yeah, it's not like it's worse now for you or anything. Okay. Okay. So normally when you're compiling with G++, there's a lot of stuff to type in. G++ main.cpp file.cpp blah, 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 blah. These are all like your source files. And you've got your executable name that comes after -o. And sometimes this is really like annoying to type out. It's just, you have to get it right. It takes a lot of work. It's annoying. So what we use here in Makefiles, which makes everything just a lot faster. And basically it sets up, it compiles stuff for us, cleans up your directories and stuff like that. Okay. Right, yes, specify a set of compilation rules. So when you're using your Makefile, instead of typing all this, you can just run make all and does that. Okay, so we do provide a Makefile to use for this course. I think in 280, we also got some Makefiles, but they were very simple. If you look at the Makefile in that we provide you, I think it's on the EX281 GitLab. It's like really complicated. There's a lot of stuff in it. So you don't actually have to understand everything in it. It's like not necessary. There's only a couple things that you need to make sure you do right. Okay. So the first thing you need to do, set the project identifier to the identifier given in the spec. The reason you do that is because the Makefile actually checks to make sure all of your code has the identifier in it before you submit, because the autogradder requires the identifier. So the identifier is usually given in the project spec. Sometimes it's given in one of the starter files if there are any starter files. Usually there aren't starter files though. So yeah, okay. Then you set the executable name to the name given in the project spec. So they're going to like tell you a specific name that's in this project spec. It might not be like project 5. It might be like, in this case, hunt, I guess. And then you set your project file variable to whatever you have your main method in. So if you put it in something called project1.cpp, this is going to figure it out automatically, or main.cpp, or even hunt.cpp. If you put it in any of those, it's going to figure it out automatically. However, if you want to name it something else, feel free to. You just need to change this project file line. So like comment this line out. Oops. Comment. You guys can see my mouse cursor, right? I'm not like looking at something.
Yeah, we can see it.
All right, cool. Okay, so yeah, so you comment this line out, uncomment this line, and put it, name it whatever you want. Cool. Now a trick. So you have to set up any. Okay. Yes. 4. Set up any custom file dependencies. So say you've got your CPP files and they have dependencies like on specific header files. You need to add those to your Makefile. There is a command called right here that I've written, g++-mm star.cpp, and that will auto-generate these dependencies. I actually added this into the slides, so this won't be on the slides you see on Canvas. I think they mentioned it. I think it's actually mentioned in the Makefile. So if you forget this command, you can just look there. And there's a bunch of to-do comments that will tell you where to fix stuff. So I will look at some Makefiles right now. Oops. Okay. Right, so, well, this one doesn't have the, oh, it does actually. Right, so the first to do right here, yeah, set your project file thing. Oh, wait, I don't know why the to-dos, there's no to-do on the identifier, but, oh, I think I know why. So this Makefile is the one that they gave in like the lab resources file, so it's a little bit different, but I mean, whatever, it's pretty much the same. I think the only thing it's missing is like executable. Yeah, it's missing executable and identifier, or maybe I can't find them, but oh wait, here they are. There. Okay, executable demo. Yeah. So here's where you set your executable. It is, I guess if you want to see. I don't know what's going on. Oh, I see. Okay, it's line 33. Next, project file. So here's that. And then at the bottom is where you see, this is where you need to add your dependencies. Okay, someone asked, are you using Ubuntu WSL for accessing Linux terminal on Windows? Yes, I am. So I'm using WSL 2, Ubuntu 20.04. WSL 1 should work fine, and 18.04 should also work fine, so that's fine. But right now, what I'm doing, I'm still SSH into CAEN, but I am like using WSL to SSH into CAEN. And then the next question, could you use any terminal to access code through CAEN? Any like bash like terminal, so ZSH, bash, so like your macOS terminal should be fine. Your Ubuntu terminal should be fine. I think that if you have any other questions, feel free to ask again. And yep, someone just answered, how do you know what dependencies you need to add? Yep, there's that command, g++-m star.cpp. I will actually run that right now. I don't think it's gonna say much, but. Yeah, so this is like the dependency. This is what it gives you. And so you just take this and copy it into the Makefile. This wouldn't actually do much, but you know. So this is what your dependencies, sorry, hold on. So this is just like a little basic thing for how a Makefile works. You have like your target name. So that's just like what file are you creating when you run, no, sorry. So you have a target name. This corresponds to a file, usually, except for in some specific cases. And then you have files that the target depends on. So when any of these files change, your Makefile is going to recompile and make this file again. And you have to have a tab character. Like if you press tab, sometimes your IDE will insert spaces. You need to have an actual tab character in your Makefile. So you put your tab here, and then you put the actual command that is going to run. And so this command is supposed to create this target file. You shouldn't actually have to deal with any of this because our Makefile figures some of this stuff out for you. This is just kind of basics to learn about it. All right. And then some of your basic Makefile commands, make or make all. Make just runs the first command in the Makefile. I think that's usually all. So what they say is it recompiles all files. I don't actually know if that's true. Yeah, I don't know it. I think it'll run make release. So I don't know if that's quite right, but whatever. Anyway, yeah, so make or make all will come back. Okay. Recompile all the files that have been changed. Make clean removes generated object files. So anything that ends with .o is going to remove, and it also will remove your generated executable. Make debug. So this is what you want to create when you're using, say, like VS Code to debug. You have to use make debug because GDB requires like some like stuff that it inserts when it's compiling. You also need to do the same thing. You also need to use your make debug executable for when you run Valgrind. It's required. Otherwise, you won't see line numbers, which you really want. Make profile. So that's for perf. I don't know the difference. I don't actually know, but I guess that's what you're supposed to use for perf. Perf is just helps you figure out like what parts of your program are like slowing you down. Partial submit. So make partial submit creates a tarball for submission, and it doesn't have any of your test cases. It just helps you so you can submit it to the autograder to see if it compiles there. It doesn't actually count as your, okay, it doesn't count as a submit if your code doesn't compile. Okay, sure. Full submit, that's what you're mostly going to be running when you're turning in your code to the autograder. It creates your actual tarball with, that includes your test cases. I don't know if I can show you. I don't know if this will help, but we'll see. Okay, yeah, so you can see full submit.tar.gz. That's what you actually end up submitting. You don't submit like your individual code files.
Yep.
Okay. Yep. Okay, that's the tarball. So I just said, make all tests. Okay, so this is if you want to make like your own test files. They're not required. You don't have to make test.cpp files. The test files that you're going to be making are actually input files, so they're not going to be .cpp files. This is just like for convenience, I guess. This is similar, I think. Yeah. So this is like this. Yeah, these three are not really required. You can just do them if you want to. Okay. Debugging with print statements. I don't know. All right, fine. I guess I'll cover this. Okay, so the Makefile allows you to utilize print statements that only print in debug modes, like when you make debug. So you can just wrap your print statements in this preprocessor directive, like if defined debug, and this will only be defined if you're calling make debug, and then it'll print this only when it's a debug. I don't personally find this that helpful. I just I just like make a debug thing and add like print statements myself. So someone asked, so do we put our test cases in test.cpp or somewhere else? So our test cases are not going to be C++ code. They're going to be input files for your for the project. So they're not going to be like, I think in 280 there's like a framework or whatever, and you have to like write and you have to assert stuff. That's not what 281 test cases are like. You have to like write an input file that could have been given by someone else and see if it exposes the autograder's faulty so the autograde will have like specific faulty implementations of the program of the program, and you'll submit it there and see if you can catch a bug in their code. That's kind of what our test cases are like. All right. So by input files, you mean .text files. Usually they're text files. I mean, it doesn't really matter what the extension is unless they specifically say. But I think you're right. They're text files. So you don't have to write the correct output file. Yeah, I don't think so. You don't have to like write the output that your program would give. Okay. Next is Valgrind. So Valgrind is a very useful tool. It's used to detect undefined behavior. That's like kind of its main thing, in my opinion. I think some people have strong opinions about what it's actually for, but I would say it's just a tool to detect undefined behavior. I think you may have used it in 280. I don't remember anymore, but I think you had the option to. But it's really useful here because it'll help you catch like times where you're accessing arrays incorrectly, and it's just, I don't know, I found it very helpful in this class. So yeah, so use of uninitialized values, that's a big one. Out of bounds reads, out of bounds writes. The uninitialized values one is big because sometimes your code will compile, but it'll still seem like it's working and you don't know why, and it'll give you like different results every time. So so I mean, if you're lucky, it'll segfault, fault, but it won't always. Memory leaks. Okay, you won't. True. Yeah, so memory leaks. So if you call exit instead of return, you might leak memory, and so Valgrind will help you catch that. And memory profiling. I don't really know what that is, so I didn't use that. Okay, I didn't set this up for us today, but this is just like what it's saying. So they have some buggy code here. It's like only 3 long, but they try to go to like the third index, but since it's 0 index, it's 0, 1, 2. It's trying to access the last makes that doesn't exist, basically. So what you do is you'd compile this and then you'd run make debug to compile it, and then just type Valgrind and then / the executable name. And then it will like give you some output. And near the top of the output, it should say invalid read of size 4. And that means that like, okay, you tried to read something that's like 4 bytes. And so this is a vector of integers, and an integer is 4 bytes. So that's what this is referring to. Invalid read of size 4 means you're trying to read an integer, something of 4 bytes, which in this case is an integer, which that you didn't have like access to. You shouldn't have access to. This thing, oh, okay. I guess you can read this. Yeah, sure. Right, and if you don't see a line number, that means you didn't do a debug build. So you need to do a debug build if you want to see line numbers. You always want to run Valgrind on your code before you submit to the autograder, because if there are any Valgrind errors, you will just lose 5% like right off the bat. How does 10%? I guess it's 5%, whatever. You lose 5% right off the bat, like if there's any error, even if it's like super minor. So you always want to run Valgrind before you submit to the autograder, especially if it's like your last submit or something. Like just make sure, because it's not worth losing 5%. Okay. Yeah, and so then once you know what lines the issues are causing the issues, you can use your debugger and figure out what's going on. Okay. So next is perf. Perf is what's going to help you find out if what parts of your program are taking up too much time. So in 281, we do actually grade you based on how much time your program takes. It's not just like, hey, did you get the correct output? It's, did you get the correct output, and did you do it fast enough? And did you take up too much memory or not? So perf will help you figure out like how much time is being spent in specific parts of your code. And that's why you want to use functions, because if you have everything in main, perf is going to say, okay, you're spending 100% of your time in main. And so that's not going to be very helpful to you, because how's that going to help you optimize it? But if you have a lot of functions, you can say, hey, I'm going to run perf. Okay, perf says it's taking like 30% of my time in this function. Maybe I can optimize that. Okay, so to run perf properly, make sure you run with G3 or OG flag. Is it O or 0? I think it's O. OG flags. This can be done with make debug. Okay, I don't know why make profile exists then, but yeah, I always use make debug. So I will try that for you live. I did not try this before class, so we'll see if it works. All right. We'll try profile. Oops. If you're wondering what any of these things mean, I have no idea. So sorry, but it's just there's a lot of like boilerplate with perf that you kind of just have to do. Okay, and I think you can just do this. Oh, cool. I spelled it wrong, I think. Oh, crap. Equals dwarf, okay. Maybe I should have copied and pasted. Oh, what's this? Can I run download debug? Debug build, okay. Right, okay, it's gonna run hello world a million times, so we'll see. It's running in CAEN, so it's gonna take a little bit longer than it would if it was running locally. While this is going on, I'll just mention Valgrind and perf. It's probably easier just to use them on CAEN. You can maybe install them locally, but it's just not worth it because you're supposed to be required to be compiling on CAEN anyway at some point. So it's not worth it to like try and install all this stuff and then like just so you can use it locally. I would just recommend doing it on CAEN. Okay, so now we can see perf report, and it's going to tell us all sorts of things. I'm going to maximize this so we can see. All right, so all of this is supposed to tell you like what function it's in. A lot of this is kind of like unreadable, like, oh, standard basic string, blah, blah, blah. I have no idea what it means. But what you need to look for in this is functions you've written. So in our code, we have a main function. We have a function 1, function 2, call 40, 30, 20, 10. I'll show you that code in a second. Maybe I should have shown it first, but I think you can use arrow keys. Yes, arrow keys. Yeah, so arrow keys enter, and that will show you like how much time you're spending in main and stuff. So here you can see, okay, you're spending 30% of your time in call 30, and it's doing this stuff. And then you're spending like 38% of your time in call 40. Yeah. How do you leave perf? Okay, control C. We're all learning things. I didn't really like perf very much, so I didn't use it, but it could be useful. I personally prefer just like spending a lot of time thinking about how to optimize before I actually had to get to perf, but I did end up needing it a couple times, so it's not like you can really avoid it. I mean, unless you're really good. But so here was the code that we ran it on. It's just like a couple functions that print hello world like a million times. And so you could see it gave us a breakdown for how long each function took. Samples, okay. Oh, right, yeah. So you want to run them on big test cases. Like you want to run perf on big test cases. If you're running it on small test cases, perf is not going to be able to wake up enough times and like get, it's not going to be able to wake up enough times and like see, hey, how much time did you spend here? How much time did you spend here? How much time did you spend here? So what you want to do is if you run it on a really big test case, perf is going to be able to like take like little, it's going to wake up and like take snippets. I don't even know how to word it, but it's gonna like take snippets and see like, okay, which function are you in right now? Which function are you in right now? And that's just gonna make your perf more accurate. Yeah, so you want large test cases. That's the main goal. Yeah, so if you only have one sample, again, run perf on a larger file. And I guess there's a perf reference guide in the resources folder. That would be on Canvas. Okay, next, C++ input and output. This is something that surprisingly, it does confuse a lot of people. I think, yeah, I learned it in 280, but I don't think everyone learned it in 280 necessarily. Or maybe they just forgot or something, because I noticed a lot of people get confused about this. So I just want to go over this again, and we will see, hopefully you guys don't have any problems with this semester. So hold on. Before I start this, someone asked a question. Just for clarification, to run perf, you have to use Makeprofile. You can't use Makedebug. I used Makedebug, actually, I'm pretty sure, and it worked. I don't think you have to use Makeprofile. I think they included Makeprofile because they, like, it's, I think they do the same thing, honestly. But if you're finding one isn't working, just use the other one. It's not like, oh, it's not, it'll only like partially work. Okay, someone asked, if I want to run Valgrind on my code in CAEN, do I need to copy my project folder into CAEN first? Is there a tutorial on that? I don't think we have a tutorial on just like copying code into CAEN. I think you kind of just have to use Git. I'm sure you could ask someone if there's a tutorial. There might be something in the resources folder. And I think there's probably some videos on the Eeks281 YouTube channel that talk about it. But oh yeah, so someone mentioned 280 has a tutorial on using rsync. So if you plan to use rsync, yes, you can use that one. And yes, the Makefile does have a command for it. Someone asks, do we have to download anything for perf? You don't have to, because everything is installed for you on CAEN. If you want to install it locally, I think it's possible, but I don't know how. So no, I would not recommend downloading anything for perf, actually. Someone asked, will slides be available to look at after lab? Yes, they are available in the resources folder on Canvas. I made like one modification, but everything else is the same. All right, so C++ input and output. So we have our like 3 standard in, out, and error. So this is called standard in, standard out, standard error. Sometimes Dr. P might refer to them, instead of by CAEN, he might call them standard in. So I just want to let you know there's like 2 different names for them. This is just like when you run your program. If your program is trying to read from standard in, it's just going to stop and wait for you to type something in and press enter. Cout is just printing to the terminal. And then standard error, yes, you will also print to the terminal, but you can redirect it if you want to. So in 280, I think we used a lot of like file stream. So if stream or of stream, that's out file stream, and then just like standard f stream. In this course, we won't be using them because most of the time we're just using input redirection. What input redirection basically means is you take a file, and what Linux does is like it like breaks the file apart into a bunch of lines, and it feeds the, well, not necessarily line by line, but it will feed it into standard in. So you don't actually have to like say, put the file name into your program. All you need to do is say, okay, I'm reading from CAEN, and then Linux will handle the rest, or Mac OS or whatever. It will say, okay, I want the next word. So that like someone types the input redirection, that file will be read into your program automatically. So someone asked, how do you suggest making test input files while we're coding? Should we automate it somehow? You could automate it if you use like some fancy tools. I don't recommend it because then you won't actually know what it's testing. Yes, you should make them while you're coding. So I think anytime you write some code and you see something like you maybe fix a bug, you can write a test input file that would expose that bug. That's what I would recommend. Personally, I didn't do that. I just made them all at the end, but it's probably best practice to do that. And I would also say I think they provide you guys with a couple of like sample tests. You will feel free to submit those as tests as well. Like you are totally allowed to submit the test inputs that we give you as your own tests. That's allowed, and they usually will catch some bugs. So, okay, yeah. So moving on. This is how you would actually use input redirection for your program. So / your executable. That's just like saying, okay, terminal, run my program. Then you have this like arrow thing that says, okay, we're going to start some input redirection. And then you have the name of your file you want to like plug into that program. So again, how it works is your computer or your terminal or whatever is going to take your input file and like plug it in to your program's standard input stream. It's not actually like your program doesn't know that it's getting input from a file. As far as your program knows, it's getting input from you typing it in on the terminal. Yeah, there's no way for it to tell. Yeah, so in this case, right, like what it says, these things are not command line arguments. So you're not going to see them in your argv because they're like your C++ program has no idea they exist. It's actually completely with the shell. It has everything to do with the shell and nothing to do with the C++ program. So yeah, like it says, you can use getLine or the double arrow, which is the extraction operator to read in your input file. And again, yeah, don't open files. Directions for redirecting input on Xcode and Visual Studio can be found on Canvas. So say you want to like debug, you would need to look at these, the files. Excuse me. Yeah, so you'd need to look at this tutorial to see how to redirect input. Visual Studio Code is a little bit more straightforward. You can just put it into the debugger. And so that's all I use. So I don't actually know anything about doing this with Xcode and Visual Studio. All right, so someone asks, since the Makefile makes .tar files, how do we run the programs manually? Do we have to compile in a .exe? Okay, so actually the Makefile makes a lot of different types of files, and it all depends on what command you're giving it. If you give it make full submit or make partial submit, it's going to be making .tar files, and that's for submission. It has nothing to do with like compiling it locally. When you're running your programs locally, you would run something like make release or make all, and that will make an executable. It's not going to be .exe at the end because like Linux programs, macOS programs, they don't need to have a .exe in the end. You just need to run make release or make all, and it's going to create your executable, and you just do /executable. That's it. There's no like, there's not going to be any .exe at the end. All right. Okay, yeah. So another thing is output redirection. So you've already learned about input redirection, like you're feeding it into the program. So this part is output redirection. So you run your executable and say your program creates some sort of output. Say you don't want it to all print out into the terminal because you don't want to like clutter your terminal and you want to be able to look at it more easily after. You use this like rightwards arrow or like angle bracket or whatever, and then your output file name. And that will just fill up that file with the output that your program normally would have printed onto the terminal. And so you can just print a C out, and it's actually going to go to this file if you do output redirection. Right. Okay. So this is actually pretty important because it can be confusing if you don't do this right. Oh, quick question someone asked. Does make full submit make a new .tar file every time, or does it replace the old .tar? So if you run make full submit and you already have a tar file in there, it will just overwrite the old one. It's not going to like make a million of them. However, if you were worried about it or something, you can run make clean and it will delete your tar file before you like do anything else if you want to do that. It'll also delete a couple other things, but it's nothing that you like should be worried about. It just deletes your object files. And if you guys have any question about like make files like object files, that can be a little bit confusing. So feel free to ask in the chat. All right. So C++ standard in. So when you're reading in input, you don't want to use any of these like flags that CAEN will set, like end of file, good, bad, fail, because those will cause more than likely, if you don't use them very carefully, it's going to cause like off by one errors, and it'll be very confusing. So the best way to do it is how we have it here. You do like while and then CAEN extraction into your like variable. The reason you can do this is because when you're doing like run CAEN extract into this new variable, it converts it into, and if you have it in a while loop, it will convert it into like a Boolean that tells you, okay, was this a successful like read or was it not a successful read? If it was a successful read, it's going to go on into the while loop and you're going to have your new value. If it was not a successful read, meaning like you're at the end of the file, it will say, okay, this will evaluate to false, and you'll say while false, which is not true, and so you won't execute for that time. So that's basically what it's saying over here. The while loop will terminate exactly when you want it. The same thing is true for getLine, except for you're getting a line at a time instead of one token at a time. Yeah, so basically you want to always do this because if you check manually, okay, is .good, you will usually have an off by one error. All right. Someone asks, what are object files? Why are they separate from .cpp or .h files? So an object file is a type of binary file. This is just kind of running back to the Makefile stuff, just like it makes object files as an intermediate step. They're binary files. So if you try to open an object file, you're not going to be able to read them. It's completely unreadable. It's as if you tried to open it executable. So what they are is, it's like an intermediate step between your CPP files and your actual final executable. So each CPP file will turn into its own object file. And what that helps you with is every time you make change one CPP file, you don't have to recompile all the other CPP files because that takes a long time. So what happens is each CPP file becomes an object file, And then all the object files are linked together to make one executable. If you've taken 370, there's like the difference between the compiler and the linker. I mean, there's more to it than that, but yeah, they're linked together. So they're already compiled basically, and they get linked together to make one executable. So say you only change one .cpp file, only that corresponding object file is going to be changed. None of the other object files are going to be changed if you didn't change the corresponding CPP file. And that's the importance of adding those dependencies into the bottom of the Makefile that we talked about earlier. If you don't add those dependencies, your object files might not get updated when they need to be. Yeah, that's the main reason. Okay, so let's move on. So say if you want to read character by character in C++, the code below does not preserve white space, right? Because, what does it say? Yes, so when you're reading character by character, using this extraction operator, it's going to skip spaces. So it always ignores any sort of white space, like new line, space, tab, carriage return, all of them it's going to skip. So it's just going to keep reading in and like take it character by character, excluding all of those. So it'll take in all of these. And what's actually going to get printed is everything without the white space. Yeah. Okay, I should have explained it on this page, whatever. So it ignores leading white space and it consumes a word until the next white space or end of line. Yeah. What's going on here? I don't think this is that helpful. All right. If you want to look at this, you can. So this is getLine. GetLine does preserve white space because it gets one line at a time and doesn't change it at all. It takes gets the whole line, and it does not get the new line though. It reads everything up to the new line, but not including it. So it grabs ex281, and there's like a hidden new line over here. It does not include that when it puts it into the string s. It's just ex281. So when you see out it, you still have to put the end line little thing. So what gets printed, ex281 is fun. It does keep all the spaces and tabs and carriage returns. Carriage returns, you usually will not deal with. If you're on Windows, we try to turn carriage returns off. They probably should be off by default, so don't have to worry about it too much. Right, so getLine consumes all characters until a given one default new line. Actually, yeah, so I kind of misspoke. What I said earlier was getLine always goes up to new line. Actually, what happens is it goes up to new line by default, but you can actually say, hey, I want you to stop on tab or space instead if you want. But just by default, it makes more sense when you're saying getLine. It goes up to the new line. All right, and so yeah, this is just an example. All right, so common mistakes. If you're mixing your extraction operator and getLine, when I say extraction operator, I'm talking about this thing. When you're mixing them together, you need to note that this is not going to read in spaces or new lines at the end of a file. So whenever you're like doing this because maybe you want to just grab one number at the beginning of the file or something, you need to make sure to read the new line at the end as well. I think there might be some quiz questions that involve that. Okay, so here we are, int n. You see in n. And so here's this file, right? So there's some white space at the beginning, white space at the end, and then there's a new line. So you read in 5, and 5 gets put into n. If you do getLine now, what you're going to read in is the new line that's at the end and the space at the end. So like you're not going to actually get the thing that you wanted. You're not going to get the next word, apple. So you need to like manually do a getLine after you do a CAEN if you're going to mix extraction operator and getLine. Right, so this is how you'd fix it, right? So you do your CAEN, and you have like a junk string, and then you use getLine. The junk is just going to be this white space, and then you have your actual words that you want to start getting getLine. So then your word will be apple. I think the project also has you. It gives you like a number as the first thing in the input, so you might have to do something like that for the project. So when IO becomes a bottleneck, avoid reading or writing character by character or word by word. Well, I never really did that. Okay, whatever. I guess you could do that if you really need to. So you could go line by line instead. So C++ streams are slower than standard lib. because I think it needs to keep C compatibility or something like that. I'm not exactly sure why, but we want to like make our code as fast as possible. So you always need to include this as like one of your first lines in main. Before you do any reading from the terminal, before you do any writing, you need to include this line, and that will speed up your code like quite a bit if it has to do with a lot of like IO. Oh yeah. So if you include this and, sorry, if you didn't include this, you probably wouldn't be passing a lot of the autograder test cases because they require you to get there in a certain amount of time. I think the reason we mention this is because it's possible that maybe students in the past could have known, or Dr. P, I think, told me that students in the past like knew about this trick and they were using it to get way faster on the autograder. So the professors just told everyone about this trick so that everyone can kind of be on an even playing field with respect to this, because it's kind of like a hack that really works a lot, like really speeds your code up. Okay, and you always have to include it just at the beginning of main is fine. Right, another IO tip. When you're printing to cout, always use \n instead of nline. So nline also flushes the output buffer every time it's called, while \n does not. Nline, that's what makes nline so much slower. And it's not slower just generally. It only comes when, say, you're writing 100,000 lines, you can see a huge difference, right? 2.5 real seconds, whereas with \n, you can see like 0.029, way faster. Flushing the output buffer, I guess it doesn't really matter, but you could also do that manually if you really want to. You can just do insertion and then flush or standard flush, I think. Okay, Getopt. I think that's what this lab assignment is about. Oh, someone asks, should we also use \n with standard error? I don't think we grade anything on standard error. If you want to for speed, say you're printing stuff out to standard error for like your own testing, yes. I can't remember, maybe they've changed it this semester, but just generally use \n standard error or standard out. Okay, so Getopt. So that's what this upcoming assignment is about, like the one that's due on the 18th. So I think, I haven't really looked into it, but I'm pretty sure it's Getopt. So Getopt Long is a function that helps to automate command line parsing. So say when you're writing code and you want to execute, if you want your user to be able to specify specific options to run your code with, that's what Getopt Long will help you do. So say you want to say, okay, the first thing, I don't know what this, actually, I don't know the context of this specific thing is, but saying, okay, let's say I want the flag first and it should have an argument of 5. Or maybe I want the flag S, which means summary or something like that. It just helps you read all this because there's so many different permutations you could be doing this in that would be really hard to manually do. So Getopt Long just simplifies this. Getopt Long is actually something from C and not from C++. So it does some kind of weird things that you wouldn't expect. So we'll go over those just to make sure that you don't get tripped up. And then quickly someone asked, so we should avoid using endl? Yes, just basically don't use it. Just output \n instead. All right. Yeah, so like I said, Getopt Long takes the work out of accounting for all these different possibilities. So here's an example of a program that uses Getopt Long. It's got this like long options array here, and then it has like this weird string that doesn't seem to mean anything. And then you've got this optarg and all sorts of stuff. So basically, this option array, you like add an entry for every option that you want to add. So say you want the action. So say you want say you want an option for someone to write the word action here. So say here's your executable. And then you could say -- action as a flag. Or number is the next one, right? So -- number. At the end, you can see here, it might be a little bit small, but action, no argument, null pointer, A. So what this A thing means is instead of typing out this whole flag action, you can just do A and it'll be the exact same. And then same with number. Instead of number, you can just do -n. That's just, Oops, 1 second. Okay, so now let's talk about this like stuff here. This line is always required. You just need to have this at the end. It's just so they know when the end of the option array is. Okay, so now this no argument. When you put this into your option array, that means that when you type in action as a command line argument, you're not going to provide a word or a number after it. Like say like, okay, say your program says, okay, I want you to determine the number of, I don't know, iterations I do. And so you provide a flag like -s and then 5, and then 5 would be the number of iterations. When you're doing no argument, you cannot put that number. Like it's just going to be like a Boolean flag egg. It's on or it's off. Whereas with required argument, you have to put that number. So -s, or sorry, in this case, -n, you do -n and then some sort of argument. So someone asks, in this context, could the command line argument be /executable var1 -- action? I'm not sure what you mean by var1. Can you explain that a little bit?
Yeah, so my question is, can like the action argument -- action be at the end?
Oh, yeah, like it can be at the end. But what do you mean by var1? I'm not sure, like, what's that? Why is that included?
It's just like I don't know, like a follow-up argument for action.
Oh, okay. So, well, action has no argument like after it, right? So you wouldn't want to put that there. But say you could do something like .exe -- number and then your argument, but you have to put it afterwards. You can't put it before. Does that answer your question, or am I missing something?
No, yeah, that answers my question. So in this case, the order in which say that your executable takes two more arguments.
Yes.
So that it takes -- number and -- action.
Sure.
Doesn't matter which way you put the arguments, like.
It does not matter. So you could put -- action, then -- number, then 5, or you could put -- number, then 5, then -- action, or -n, 5, -- action. Like it doesn't matter. It could be any. I think, right? Whoops. Here they have a bunch of different examples for how it could be done. Like your program has to be able to support all of these, which is why we even use Getopt in the first place.
Oh, okay, thank you.
Right. Okay. So next thing, there's this string in this whole like this crazy while loop thing. There's Getopt, Getopt Long, whatever. There's this string right here. This is just a thing that allows you to use the short options. So you need to put kind of like all of your short arguments into this string. So A is like your short argument. Sorry, not short argument. I don't know what to call it. I guess short flag. So A is like the flag for action. So if you want to type -a instead of -- action, you could do that. Then you have to do n for number. Now you can see there's a colon at the end. Colon at the end means, okay, the thingy before it requires an argument. Okay. Now, yeah, okay, I'm actually going to start typing a couple things because it might be confusing. All right, so say we have, yeah, here's your string. Say action requires an argument, you could do A:(n:) quote. But since action doesn't require an argument, we just don't have that there. There's also a third thing here that we could do instead of required argument or no argument. You could do optional argument, and that requires 2 colons. So it'd be like if action had an optional argument, you do A:(n:). Someone asks, what file is this main function in? I mean, I don't know the file name. I think they do provide it somewhere. I think probably in the lab 1 resources, but I don't know if we actually provide it. This is just kind of an example. Right. Oops. Right. So that's how you set up this string thing. Next is optarg. So optarg is actually a global variable. which is why you can never see it like actually get initialized. It's something that Getopt Long does for you. So you don't actually have to worry about how it gets initialized. Just know that it does. So say you want to find out what number the user provided when they did -n space 5. That's what you use optarg for. So you need to cast it, or sorry, you need to use the A2I function in this case because I think A2I turns a string into an integer. So that's what this is doing. So we're saying, okay, we have our optarg string and we know it's supposed to be an integer. So I want to turn it into an integer, and then you can like cout it or store it into a variable or something like that. Perhaps optarg was a string. Then you would just take optarg and use it as your output. Every time you loop through, optarg is going to be reset to like something new, unless I guess there's no argument. I'm not sure what happens to optarg then. But yeah, so every time you loop through, optarg is going to be reset. So you need to like store the output of optarg. You can't say, okay, optarg is going to be around after this while loop, because it might change. Right? And notice that it's a C-style array, C-style string rather than a standard string. So that's why you have to use A2I instead of S2I. I think there's one more thing. Right, with optional arguments, if they choose not to include an argument, I believe optarg will be set to 0. So you can just check if optarg is 0, then they didn't provide an argument. Okay, so we're gonna finish up. Well, I don't know if it's quite the end, but we're getting closer with some talks about abstract data types. Oh, someone asks, so what does optarg store? I'll just go over that again. So it is a C-style string, and it stores the argument that like comes after something like number. So say you did -n space 5, optarg would store 5, although it would be in a string, so you have to convert it. So if you said, okay, so someone asks, so if you said --action and --number, optarg would be 2. No, sorry, I might have been unclear. Optarg doesn't tell you how many things you've provided. It tells you like what the value of the argument that's provided is. So say we have a .executable, and then we do --action. Since it takes no argument, does nothing. Then you do --number 5, right? So what happens is optarg is going to store 5 in the case that they've entered number, right? C strings for number. Okay, so here we go. This I probably should have covered a little bit better. So what they're saying is, so some people are asking like, what would optarg store if there's multiple required arguments? Or how does optarg know that the C string is from number? Is it because it's in case n? So if you notice, this is in a while loop. So what's going to happen is it's going to loop through every single argument. Well, if there was an argument. So say, sorry, not argument, option. I think option is the best thing to call it. So say, okay, we're going to loop through the provided option. If it's named action or A, then we're going to activate case A, and we're going to do whatever happens in the case that there's action. Then it'll loop through again and say, okay, what's our next argument, our option? Oh, number is the next option. Then I'm going to set optarg for number, and then you have to write your code specifically in this like case. So you notice it's a switch statement, right? It depends on what case we're going, and it loops through. So it'll like change every time it loops through. And that's why I mentioned you have to store the output, because it's going to loop through a bunch of different times. It won't be like happening one time. Does that clarify, or do you guys still have more questions? If you do, okay, got it. So if you do have more questions, feel free to ask again. Right, so abstract data types. An abstract data type is basically like a more, I guess, abstract way to talk about a data structure. A data structure is a very specific implementation of a data type. So if you've heard of standard stack, that's a data structure because it's an implementation in the C++ standard of like how to use the abstract data type of a stack, or a queue, like standard queue, or standard vector. Those are all implementations of specific abstract data types. So what they do is you define a collection of valid operations and their behaviors on stored data. That's what an abstract data type really is. So when using an interface, you don't have to worry about the implementation. If it was changed, your code wouldn't really have to change. Okay, that's kind of not related, but okay. Want you to understand? Yeah, so we want you to understand like when to use a specific abstract data type, when to use like a queue, when to use a stack, when it's best to use a vector, or maybe when it's best to use a Deque. And then how your choice of ADT affects time and space usage. So sometimes you'll have one ADT that's like really efficient on time, but not efficient on space. So you might have to make that trade-off and change it to something that's more efficient on space and less efficient on time, because you need to satisfy all the things on the operator. Right. So for each ADT, you'll define a set of operations and their behaviors. So for a stack, stacks and queues both have these like operations defined for them. So we'll just go through. With push, you're adding a value on top of the stack. Whereas for the queue, you're appending a value to the back of the queue. Then for pop, you remove a value from the top of the stack. And then for a queue, it's removing the value at the front of the queue. Just give me a second. I'm going to look. Can we talk more about queues and stacks? No, I don't see it. Okay, well, I might talk a little bit more right now then. Whereas with top front, you return the top value of the stack instead, or the front value of the queue. Size, pretty self-explanatory, number of elements. Empty is it returns a Boolean on whether size is 0. So someone asks, is an object a kind of ADT? I would say no. An ADT is just kind of like an idea. Like, okay, hey, we have this idea for a stack, and it should support pop, push, all those sorts of those things, but it's not like any specific implementation. It's not a specific instantiation like an object would be. It's just saying, okay, like a stack is an ADT because like, hey, we know that we want to be able to put stuff on top of the stack and pop stuff on top off of the stack. Someone says, so we are not creating ADTs. Yeah, that's right. We're not creating ADTs. It's just something we talk about. So notice here for these stacks and queues, they all support push, pop, top, front, size, and empty. But you don't have like random access of elements in the middle like you do for a vector. If you do want that, you need a different ADT. So like what kind of use cases would you have for a stack or a queue? Okay, well, yeah, okay. Anyway, so what kind of use cases might you have for a stack? I can't think of one in a program, but like in the real world, you might like stack up your most recently used things. And then you know that, okay, I'm the most likely thing that I'm going to use is the thing I most recently used. So you can pull the same thing off of that stack. That's not a very good example. Queue is a lot easier to define in the real world. Queue is like a line. So like it's a first in, first out data structure. So the first thing you push onto a queue is the first thing that comes off. So say you push 10 things like A, B, C, D, E, F, and then you pop something from the queue. The first thing that comes out is A because it's a queue. You want to like keep the ordering like that. Whereas with a stack, if you push A, B, C, D, E, F, and then you pop, you're going to pop F off because that's the thing that was most recently added to the stack. Kind of opposites. Yeah, so stack, you kind of think of vertically. So like you're stacking things on top of each other and then you pull things off the stack. A queue is like a line. You kind of think of it horizontally. Like this is not like scientific. This is not like, oh, this is how it's defined in code or anything. It's just kind of, I'm just talking about it. You have your queue that's kind of horizontal. It's like a line of people. Like the first person comes in, last person comes out. All right. Oh yeah, and we're going to cover these more in depth later, but I wanted to cover them now. So a Deque. A Deque means double-ended queue. So basically, it's kind of like a stack and a queue kind of together. You can choose to treat it like a stack at one point, choose to treat it like a queue. Sometimes it's best to use it. I think they're useful in project 1, maybe. So for a Deque, you have push front, pop front, front size, where they add values to the front, remove values from the front, get the front value, return the number of elements, and then push back, pop back, back empty, kind of similar. If you only used push back and pop back, it would simulate a stack, or push front and pop front. That's also an option. Like push back, pop back, stack, push front, pop front, also stack. If you wanted to use push back, wait, did I say that right? I think so, okay. If you want to use push back and pop front, now you're simulating a queue. Or push front and pop back. You're simulating a queue because you're like taking off of opposite sides. Whereas with push back, pop back, you're taking off the same side. You might also notice Deques also support operator with like the square brackets position, similar to like vectors or arrays. So that also gives them sort of efficient random access to all elements. You don't have to like pop everything off to get to a specific element. So you can use them to represent a list. What I will say is though, if you can use a vector because vectors are much more space efficient and they're also very fast compared to Deques. I kind of assumed in the last slide that you knew what a vector was because I think you guys have worked with them in the past. But yeah, basically they're similar to Deques, but they lose push front and pop front in exchange for better performance. In fact, you can use a vector to implement a stack, and you just assume that the end of the stack, the end of the vector is the top of the stack. And actually, it covers all necessary operations, and it's really fast. So vectors you normally want to use because it's super fast, and just they're very useful in this class. You never want to use like linked lists or anything. Vectors just mostly for everything. Sometimes you'll need a Deque or a queue or a stack. The implementation is, oh wait, no, never mind. So I was just thinking about Deques, but yeah, we'll cover the implementation later for vectors, but these are two things you really need to know. The difference between resize and reserve. So they kind of sound similar for a vector, but they're actually like pretty different. And if you use them incorrectly, you can get really confused. So we really want to cover these. And also, last point on this is just use vectors to hold reference data that can be identified by indices. So basically use them similar to arrays is what they're saying. So consider the difference, vector resize versus vector reserve. What's the difference? Resize changes size while reserve changes capacity. So like reserve, it's hard to kind of see what it does because there's no obvious thing that it does. All it does is make your code faster if you're using it right. Well, resize is a lot more obvious as to what it does like right away. Just to see what's the next thing. Okay, well, I'll discuss it and then I'll maybe show you an example. So vectors have a data pointer, a size, and a capacity. The capacity is how much room it has, and the size is how many elements it actually contains. Okay, so the way vectors are implemented, which might make this like easier to understand, they actually have a pointer that points to a dynamically allocated array. Like you don't have to think about it, but like it does have a pointer that points to a dynamically allocated array. So the capacity is the length of that dynamically allocated array, while size is just like how many elements we're using of that array. So resize will take your array and like reallocate a new one, copy everything over, and like say, hey, we're using this entire thing. So if you call push back after resize, it's going to like take, since you've resized, your vector is now full. Like the capacity is the same as the size. So if you call pushback after resizing, it's going to double the size of your vector under the hood. So it's going to take up twice as much space under the hood. Although if you do dots, sorry, I should have said capacity. Doubles the capacity of your vector under the hood, and it's going to take up twice as much space, like on the stack and everything, and the heap, I mean. But you won't actually see it. It'll look like it just increased by 1. Reserve does not change the size, but it does increase the capacity if it's needed. So if you call vec.pushback, it adds the next element normally. Does not do anything. Okay, yeah. So it doesn't do anything if the new capacity is smaller than current capacity. And right, so someone asks, does resize create new elements to fill up the new size, like placeholder data? Yes, it does. So it value initializes all of these elements. So it depends. You sometimes learn this in 280, sometimes you don't. Default initialization is different than value initialization. But to keep it like short, value initialization basically like gives it a sane default value. So say you have a vector of integers. If you value initialize them, it's going to initialize them to 0. Default initializing them would initialize them to whatever values in the memory, which is kind of scary, but value initializing it will initialize to 0. It's basically going to call the constructor if it's an object. It's going to call the default constructor. Okay. So this is still a little bit confusing maybe. So we'll take an analogy. So you have a bucket and you wanted to put water in it. Let the bucket represent a vector. When you resize the bucket or vector, you change the amount of water in the bucket, and what they don't say here is, and the size of the bucket. Like, if you resize it to be like 100, the size of the bucket increases and the amount of water in the bucket increases. When you reserve, you change the size of the bucket or the capacity of the bucket. I should be using capacity. I'm sorry if I'm mixing up size and capacity. There is a difference, but colloquially they sound similar, right? So what I should have said is here, when you resize a bucket, you change the capacity and the size. So you change the amount of water and how big the bucket is. When you call reserve, you change how big the bucket is, the capacity, but not how much water is in it. So you might not fill it up with more water, but you replace it with a new, bigger bucket. So an example here, vector.reserve 10. What happens if you try to index into the 0th element? What's going to happen is this is like not valid because you've reserved 10 spots, but you haven't started pushing back any of it. So it's kind of all like hidden. So you can try, it'll probably throw an error or maybe a segfault or probably not a segfault, but it'll throw some kind of error perhaps. And this is just like incorrect. So when you do is vec.empty, even though you've set like the 0th element to 5, vec.empty is going to return true because the vector doesn't actually contain anything. It just has a big capacity. It doesn't actually have any water in it. Like it's like you tried to add water in it, but you didn't use pushback, right? So remember, the reserve doesn't actually add elements to the vector. There's no element 0 there to access. There's nothing to change. Yeah, resizing, yep. In summary, resizing changes the number of elements. Reserving changes how many elements a vector can hold. Okay, because we're treating vectors as an ADT for now, you don't have to worry about why vectors have a separate capacity and size. Sorry, I already explained it for you guys, but whatever. It's just part of the specification for this ADT. So capacity increases are expensive and they should be minimized. The reason for that is, like I said, you have to copy everything over and like double the array basically. That means is if you know exactly how many elements you're going to have, you should reserve beforehand that number so that you don't like waste a ton of space. Yeah, so like I said, right here, if you know what size will be in advance, use one of these functions. Oh, right. So I'm using the condensed slides for this lab. There's also like long slides that go into like, oh, what if you want to initialize multi-dimensional vectors? But they have like 4 slides for like, oh, you could do it this way or this way or this way, and they're all like the wrong way. Basically, if you want to initialize a multi-dimensional vector, so say think like a 2D array or a 3D array, but vector instead, you can do it all in one line. You say, hey, okay, I want a vector of vectors. Sorry, yeah, vector of vectors that contain integers. Then you name this like big vector. Then you say, okay, how many elements do I want this vector to have? Then I want to say, okay, what should each element be? Since it's a vector of vectors, each element should be a vector of integers. And how do I initialize this vector? It should be size 10 and they should all be 0. So someone asks, why would I want to use reserve or resize over the other? It seems like resize would do everything I want to do. So I guess I can try and write an example really quick. I will come back to multi-dimensional vectors, but basically there's not much beyond do it like this. Okay, so say we're reading in from CAEN, right? And we have a vector of integers named vec. So say, I mean, this is kind of contrived. Like there's other ways to do this, but this is how I'm going to do it. say I know, hey, this vector is always going to be, we're going to get 20 values from CAEN. We're not going to get 21. We're not going to get 19. We're going to get exactly 20. I'm going to say vec.reserve 20. And that will make sure that we don't have any like costly capacity increases. When I'm looping through, I can say maybe vec.pushback value. Now say I want to do something special every time the vector size is a multiple of 3. If vec.size equals 0, right? So now say every time the vector size is a multiple of 3. Again, it's kind of contrived, but I'm trying to come up with an example, and there are examples that are better. But so if I want to do something special, every time the size is every time the size is a multiple of 3, you could do something. Now, say you did this, but instead, actually, let's do this. You resized. Instead of doing pushback, what you do is, well, I guess you'd have to have a counter now. So maybe it'd be easier to do a for loop, but I'm going to make a counter. So now, since you're resizing, you're just going to change elements that are already there. So you're doing this. Now what's going to happen is vector size is always going to be 20. It's not going to ever be a multiple of 3 because it's always 20. Even though you're like going through and reading all of these things, like it's always going to be 20. And this is not really a good example just because you could use a counter to do the same thing. Like it's not that helpful. But there are cases where you want to use reserve over resize because you don't want everything to be initialized right away. You want to just put it in when it's ready, basically. Okay, so back to multidimensional vectors. Yeah, you can initialize them basically like this. I would just recommend if you forget how to initialize the multidimensional vectors, come back to the slide. It is like slide 60 on the condensed slides. It's by the end. It should tell you how to do them. You can also do it 3D vectors. Yeah, that's basically it. You'll find it useful for project 1. So, right. I guess there's just some questions to think about. Maybe in like in-person lab, I might like have asked them, but it's kind of harder to do participation when we're on Zoom. So here's some situations. What ADTs would come in useful? Are there any ways that we can use a faster ADT instead? So we want to keep a list of the names of people in the order that they entered a classroom and be able to find the name of the nth person who entered. So you would want to do vector, most likely, because you could use Deque or vector, right? Because you need random access. You need to be able to find the name of the nth person who entered. So a vector or a Deque would work, but because it doesn't mention anything about push front or pop front, you probably just need a vector because you just need to know the find of the name. Sorry, you just need to be able to find the name of the nth person who entered. Okay, say we want to simulate traveling from one road intersection to another, and then backtrack in the opposite order once some condition is met. Stack. I think, I'm not sure actually, but yeah, say you want to backtrack somewhere in exact opposite order once some condition is met. That's what you use stack for. Or say you want to serve requests received by modem in the same order that they were received in, queue, right? You want to do something that like first in, first out. Like you get there first, that means you get served first. And there was a question in the chat, are we allowed to use Deques or are vectors recommended to build stacks queues? Someone answers Deques are allowed. That's true, Deques are allowed, but you don't have to build stacks or queues. You can just use standard queue or standard stack. There's no need to like build them. Yeah, but I think you can use standard stack or standard queue, but you can definitely use Deque. Okay. So project one tips. A lot of these are pretty basic, just like write modular code. You want to separate your code into functions to make it easier to deal with. Think hard about your data structures. Your project is strict on memory. Many of them are actually. Some of them, they'll be a little bit more lenient, but a lot of them will be tough. So you want to think hard about your data structures before you start coding, like start designing first. Look at Piazza posts. I know Piazza, there's a lot of posts on there. We also have our Discord, I guess. You can also look there. That's harder to search though. So Piazza, there's tons of posts. Probably by the end of the semester, I'm guessing 6,000 there'll be 6,000 Piazza posts. Those can be very helpful. It's like filter by your project and scroll down and see, or search even. Submit as soon as possible. Often it takes many submits to get their desired score. I've had it take anywhere between 1 submit and like 15 submits to get the score that I wanted. So you never know exactly how long it's gonna take. Right, and what's nice about the autograder is when you're writing your test cases, if your test cases catch a bug in your own program, it will tell you. So because you don't know the correct output for your program, you might not be able to see. But if you've written a test case, the autograder will be like, hey, your test case exposed a bug in your program. So you can debug that. When you're passing things into functions, you want to pass by reference almost always, unless it's a primitive type like int, char, bool, stuff like that. The reason is with like big objects, if you pass by value, you're going to make copies, and that's going to be slow. And again, making copies and being slow in this class is not good. You want to pass everything by reference when you can. And you want to break up the works into parts so that it's not so overwhelming. Makefile is pretty short. Getopts, storing input, routing, backtracing, all that stuff. Break it into parts. And then this is just some general steps for coding problems. I think you can just come look at these. I don't think I have anything to add to them, but there's some steps in this slide if you want. Okay, so now we have the handwritten problem. So remember, this handwritten problem is due this Friday on Gradescope. You can type it up. You can, so you're typing it up and you can submit as many times as you want. It will give you like test case feedback. You don't actually have to pay attention to the test case feedback if you don't want to. It's because like it's not graded on like perfect accuracy. You don't have to get every test case right or anything like that. You just need to submit something that shows that you put like some effort in. Can you work with a partner for the handwritten problem? Yeah, I don't think you can work with a partner on the handwritten problem. You can discuss like ideas, but you cannot like say, okay, we're gonna both work on the handwritten problem together and we're gonna both like write the same code. Don't do that. You can discuss ideas like, hey, maybe we should use a linked list, or maybe we should use the double pointer method to do this. But yeah, generally, like keep collaboration to the same as you would for a project, not a lab. I mean, I know this is a lab, but not a lab coding portion. So this week's handwritten problem is use the starter files found on Canvas under lab 1. Okay, yeah, complete it. Completion of the project problem is worth 5 points. So you're given a node structure that are not contiguous in memory because it's going to be a linked list basically. You need to check if this doubly linked list is a palindrome. Write the implementation for is palindrome in O of 1 space and O of n time. Someone asks, so it says it should run in O of n time. We can make it run in O of n squared time and that will be fine. Yes. You can make it run in O of n squared time. You can fail to solve the problem at all. If you're really stuck on it, that's also okay. It's totally fine. Just put an attempt. I've seen some people, they submit a blank starter, like just the starter files. That will not get you points. If you just submit a blank file, that's not going to get you points. If you submit a file where you just loop through everything and don't even do anything, you might get the points, but probably not. Was this the end? I think this is the end of the slide deck. So we were discussing like in our staff meeting whether we want to do this. This is the end of the lab. There's like no reason you have to stay after this. You can do the handwritten problem like with by yourself before Friday if you want. But what we were discussing is, if you want to, you can stay, join a breakout room, and discuss it with a couple other people, and then say, yeah, you can discuss this problem like kind of generally without like going too into it, and see like what approaches you would use, and then we can come back and I can talk about the solution if you'd like. If you guys don't want to, go ahead and leave now. I'll give you guys a minute or so to work on it and leave if you want, and then I will start the breakout rooms. And then we can come back. I'll talk about the solution very generally afterwards. Okay, so I'm going to start the breakout rooms. Just remember, just discuss like basically what you think you would do. I'm only gonna give you guys like a couple minutes just to talk about it, and then we'll come back. I'll talk about like the correct solution generally. Okay. We're just waiting for a couple people. And then when they get back, we'll just have a high-level overview. I'll talk about like kind of what the solution is, and then you guys can go implement it later. All right, so I think everyone is back. So what is the solution to this? Basically, what it is we're checking for palindromes. So actually I might ask, does anyone want to talk about what they discussed, maybe like ideas? It's okay if you don't, I can just talk about the solution, but.
In our breakout room, we discussed how like you're gonna have to move the start and end node through the word or whatever we're dealing with here.
Yeah. And
then we were trying to discuss how you'll know that you're at the edge of the word once you move end all the way to the front and start all the way to the end.
Yeah.
And we think like we discussed how you would know if like say end's previous pointer. You can just pick one, end or start, but we picked end. End's previous pointer is null pointer. That means you're at the beginning.
Okay, so that is one idea, right? So you're saying like, okay, go all the way through. So how would that check if it's a palindrome? Like, can you explain about that?
So while you're moving them through, you need to check that each character is the same.
All right, so you would just go through, send them all the way. So sorry, send them both all the way through, and then once they're like at null pointers, like you'd say, okay, we're done. And as long as they were both the same the entire time, it's a palindrome, right?
Yeah.
Okay. That could work, but it's a little bit, well, no, technically it does work. But there's a faster way to do it. Did anyone else discover that? I mean, it's still a similar solution. You can just end early.
You could meet the characters in the middle.
Right.
The main problem is whether the word is a odd number of letters or even number of letters. So whether like they'll both land on the same letter if it's an odd number, or never kind of like land on the same character again.
Right. Yeah. So yeah, basically it's just even or odd. But the idea is you stop in the middle, basically once the pointers reach each other or are about to reach each other. So if it's an odd number, you can just say, hey, when they reach each other, stop, we're done. But if it's an even number, like say when they're about to reach each other, once you've checked all of those the values are equal, then you say, okay, they were all equal up to now. We're about to reach each other. Let's stop and return true because it is a palindrome. Now, if you ever go through this thing and you find, hey, these two nodes aren't equal, they don't have the same value, you can return false, and that will be that because it's not a palindrome. That's basically it. I don't want to provide the solution because you do actually have to write the code, but I'm allowed to like give stuff away. So that's basically it. That's the end of lab 1. It was great having you guys. Oh, someone asks a question. How do we know the length of this sequence? So we don't know the length. You just keep iterating through until you reach the middle. And you can tell when you reach the middle by saying, hey, like you need to do some comparisons between the start and end pointers. All right, so yeah, it was great having you guys. First lab. You're gonna do great. Goodbye.
Bye. Thank you.
Bye.